With the development of power electronics technology, various new energy technologies such as wind power and photovoltaic, as well as the continuous operation of impact and volatile loads, have brought about numerous power quality issues in the power grid, including harmonics and flicker. Additionally, the widespread adoption of electric-sensitive devices leads to an increasing demand on systems' power quality. Power quality equipment can now effectively address these issues and ensure the normal operations of such devices. Excelpoint, a leading regional distributor providing quality electronic components, has more than 30 years of experience serving clients in the power automation and power transmission industries. As an Analog Devices Inc. (ADI) authorized distributor, Excelpoint recently launched a compact power quality analyzer solution, EP-PQA-S1, that meets the Class S standards and had passed the SGS electromagnetic compatibility testing. The core components of the solution include the ADI Power Quality Monitoring Device ADE9430 and Cortex M4 Core MCU Max 32650. It operates on ADI's Class S standard power quality software library, which is perfect for powering large factories and mines like substations, photovoltaic power stations, and metallurgical plants. The system is able to monitor real-time power quality parameters at public connection points, capturing both steady-state and transient data. The device comes with a built-in 2-inch IPS LCD screen allowing you to view the power quality parameters via the operating panel. LED lights indicate the working status and the GUI on the PC display 4 interfaces: RMS, Hertz, and flicker, harmonics, waveform, and system, displaying fundamental voltage and current parameters, harmonics, waveforms, inversion information, respectively. Allow me to introduce the remarkable Excelpoint's PQA Class S solution, the motor damping test system. The hardware components for this testing platform includes a compact DIN rail meter power quality analyzer, which is compliance with the Power Quality Class S standard, an AC motor, hysteresis brake controller. This solution uses a coupling to connect the AC motor with the hysteresis brake. By adjusting the excitation current of the hysteresis brake through the controller, different torques are generated. This is used to demonstrate the changes in harmonics and related power parameters of our designed power quality monitoring device under different damping conditions of the AC motor. Follow the system diagram displayed on the screen and connect the hardware accordingly. Next, launch the PQA computer software to access the GUI and observe real-time power quality parameters, including harmonic components, PQ events, and more. Next, we will demonstrate the changes in power grid quality parameters when the motor operates with minimum and maximum damping. First, set the motor damping to the minimum and turn on the power. At this point, you will notice in the GUI that a PQ event has triggered a voltage interruption event. The histogram of current harmonics provides a visual representation of the various harmonic conditions. For instance, the third harmonic represents approximately 8% of the fundamental wave. Users can access all the relevant power quality data through other interfaces in the GUI. Here, you will observe a significant increase in the harmonic components when motor damping is increased. Currently, the third harmonic makes up about 16% of the fundamental wave. Through the use of the power quality analysis device, we are able to observe the variations in the alternating current, AC, motor harmonics under 2 different damping conditions. Excelpoint's compact power quality analyzer rail meter solution, EP-PQA-S1, empowers customers to develop their own power quality analyzer products swiftly. For more information, please visit Excelpoint's website.